Hi everyone, in this video we are going to discuss how to solve a coding challenge called set matrix zeros. Let us first understand the problem statement. Consider we are given a n by m matrix of integers m. If m of ij is equal to 0, then the entire row I and column j should contain only zeros. And now we need to write a code for this to accomplish this task without using any extra space. That's the condition here. Example, this is the given matrix. You can see here it's a 5 by 8 matrix. 5 with you can see 5 rows and 8 columns here, right? And we can notice two zeros here in this matrix, so indicated in black. You can see here the first zero is at 0 comma 4, and according to the problem what we need to do is we need to set the entire 0th row zeros and fourth column also as zeros, and then we can find another zero here at 2 comma 6 location, second row and sixth column. So the entire second row has to be set zeros, and the sixth column also should have all the zeros, and we can see the solved matrix on the right here clearly, right? So this is the problem statement and this is what we need to achieve, right? So a naive approach to solve this problem consists of looping the matrix, and for each I comma j which is equal to 0, we can set the complete row I and column j to 0. But the problem with this approach is when we traverse the cells of the other cells of the matrix, right? Other cells of the matrix. So we'll find zeros and apply the same logic again. So there is a big chance that we'll end up with a matrix of zeros, right? So that doesn't work. And one can think of an easy to implement approach where we can store the locations of the zeros, and at a second traversal of the matrix, we can set the corresponding rows and columns to zeros. But storing the zeros means again we are using some extra space, which is not allowed by the problem. So we even can't actually take that approach, right? So how to solve this problem? We are going to use a trick here. The trick consists of using the first row and column of the matrix to mark the zeros found in the rest of the matrix. For example, so in the same matrix, if you see here, we have a 0 at 2 comma 6 location, right? So whenever we find a 0 at cell 2 at any location, right? Say for example 2 comma 6 here, we set the second row and second row first column, right, as 0, and you can see m of 0 6 0 6 is 0th row sixth column. We are going to set it as zeros. So whenever you find an element, so its corresponding first row and its corresponding first column, we are going to mark them as zeros. That's how we indicate to set zeros accordingly, right? The next thing we are going to do is we are going to do this for the entire matrix, for all the elements in the matrix, and finally we'll loop through the first column and propagate each zero that's found on the row. And after that we can loop through the first column, first row as well now, and propagate each zero that's found on the column. So that's what we can see here, right? So for 2 comma 6, this is what we can achieve. And how about the potential initial zeros of the first row and first column? So even first row and column can have zeros, right? So how to actually differentiate them, that zeros, the initial zeros and the one which we are marked earlier, right? So how to do that? So we can tackle this by starting. We will start by flagging whether the first row or column contains at least one zero, and finally we will use this to set the complete first row and column to 0 accordingly. And this we are going to do, we are going to set the flag at the very beginning, right? So this is how we are going to solve this problem now. So let's see this in terms of code now. So I have taken a matrix here. uh, Whatever we have seen in the example, I have taken the same matrix. Say, you can see the same elements here. We have 0 at 2 comma 6 location, and also we have 0 at 0 comma 4 location, right? And we have a method here which takes two-dimensional array, integer array m as parameter, and this method returns nothing. So the first step, what we are going to do here is we wanted to find whether the first row or column has at least one 0, right? So for that we'll have two flag set, so where we'll say first 0, false, and we'll have another flag for column. If first column has any 0, right? So first we'll have two flags for this, and we'll start looping through the first row, right? I less than m of 0 dot length gives us the first row count. Like there can be any number of columns for the first row. We are going to loop through all those columns in the first row, right? And m of 0 of I gives us, we are going to verify this. So in the first row any column has 0, then we will say that the first row 0 is true, and then we have at least one 0, right? So we can break and come out of this loop, and we'll do this to find out columns as well. Like we'll loop through all the rows for the first column m of I. So this gives us the first column. If it has zeros, then we'll mark first column has zeros and we'll come out of the loop. We'll finally use these flags to set the entire first row and first column to zeros if these values are true, right? Once we are done with doing this, what we'll do is, according to the algorithm, the first thing what we discussed, we wanted to mark the first row and the corresponding first column to 0 whenever we find an element as 0, right? And I'm going to start my index for the rows with 1. As we already had flags for first row and first column, I'm going to start the rows with 1, and till it has to loop through till all the rows for the matrix, and for each row which is indicated with the index I, and for each column, even I am starting my column also as from 1 less than m of I dot length gives us the length of the columns for that particular row which is indicated with I, right? Now what do we see? If the element present at ij, ith row and jth column has 0, then we wanted to set its corresponding first column to 0 and also its corresponding first row to 0. We'll mark this. And once we do this for all the elements in the matrix, then we'll use this to set zeros accordingly, right? Now we'll again take like I equal to 1 index, and for all the rows, and we'll take j as index to loop through all the columns for each row indicated with I, and then we'll set the element to 0. When do we do this? If we find, just now we actually marked the zeros in the first row and first column, right? So that is what I am writing the condition here. If we find 0 in the first column, or if I find 0 in the first row. So you can see here 0, this indicates the first column, and here m of 0j indicates the first row. So if either of it is 0, then we can mark that element as, so if the element we can mark that element as 0, right? So this is what we did, and this will be done for all the elements in the matrix. So in the first step we have set the zero, we have marked the zeros in the first row and first column, and we are using that marking to set the complete row and columns to zeros here. Now finally what we need to do here is, we need to check for the first column and first row. So if this is true, if first row has any 0, then we loop through that row for all columns what we are going to do here is we are going to set zeros for the complete row. If first row has zeros, meaning we wanted to set the complete row, the elements of first row, we need to set it to 0. That is what we did here. In the same way, if our first column has at least one 0, what we are going to do here is the same thing. I equal to 0, then m dot length for all the rows in the first column. So m of I 0 gives us the first column, right? We are going to set all the elements in the first column as zeros. As first column has, we found it here, the first column has 0. If it has first column has at least one 0, all the elements in the first column will be set to 0. And with this loop, we are going to set all the elements in the first row as 0 if at least first row has one 0, right? So now we are done with solving this problem. So let's call this method in the main method. And we'll pass this matrix, right? And to view the matrix, right, how it is before setting the zeros and how it looks after this after setting the zeros, right? So we'll write a method here, display matrix, which takes the matrix as input, and let's create a matrix now. We wanted to loop through all the elements in the matrix. So m dot length gives us matrix dot length. Yeah, we can do matrix dot length as well. For int j equal to 0, j less than m of I dot length gives us the number of columns for ith row. Okay, this is matrix. Dot length, right? We'll display matrix of ij, each element, and we'll leave some space after displaying each element. And once we are done with displaying one row, right? So all the columns in one row, then we wanted to leave one new line character. So we wanted to print the next row in a new line character, right? So we are writing this statement, right? And also we'll have one more new line character here. Whenever we call this method, right, we wanted to start printing the elements in a new line. All right, now let's go back to the main method again and display matrix, right? So what we'll do here is we'll just write it here as before setting zeros. This is the matrix. We are displaying the matrix and we are setting the zeros, and then after setting the zeros, we'll call the display matrix method again. Now let us execute this program. And we can clearly see here, okay, there is ones and zeros. Okay, why did it print it like this? Let's check it out. All right, the issue is we are printing the element matrix II. It has to be ij, right? Ith row, jth column. Let us execute the program again. And this time we can see before setting zeros, this is the matrix we have, the original matrix. And we can see after setting zeros, this is the output, right? So the alignment is not clear. So what we'll do here is we'll write some small logic here where if the matrix element value is less than 10, right? What we'll do here is we will just add one more space here. Now it is better, like alignment is good, and we can clearly see here. So we had 0 at 0 comma 4, and all the 0th row has zeros, and fourth column also has all the elements marked as zeros, right? and we can see the element 2 comma 6 was 0, right? So we can see here all the values. This is 2 comma 6 0, it was there here, right? 2 comma 0, and the entire second row has the elements marked as zeros, and even sixth column you can observe all the elements in the sixth column are set as zeros, right? So this is how we solve the problem of setting matrix zeros in it, right? Without using any extra space. You can clearly see it here. We didn't use any extra space. We did solve this problem in place without using any extra space, right? So this is how we can actually solve the problem of set matrix 0. That's all for this video. Thanks for watching.